Alright, sixth graders, today we're going to be kicking off our geometry unit by looking at some of the vocab that we'll be using over the course of this unit. All the vocabulary that we're talking about today are the kind of the basics. We won't quite get into everything because some of it should be review, but just some of the more commonly used terms that we're going to use. The basis of most geometry is all around angles, and an angle, as a review, is really just the distance between two intersecting lines, and we're always going to measure these in degrees. Part of the angle are some different pieces. One of those pieces is what's called the vertex, and the vertex is going to be the meeting point of two intersecting lines. So that's one of parts of the angle, and then the other part of an angle is what's called a ray. And a ray, thinking like a ray of sunshine, is going to be a line that only has one endpoint. Now, realistically, the definition of a line is that it goes on forever in both directions, and then a line segment has two endpoints, whereas a ray is just going to be a single line that starts with an endpoint and then goes on. So this would be an example of a ray. Looking at angles, there are three different ways that you can name an angle. So if we look, for example, at our angle here, you can see that we have 3 points on there. Most commonly, if you have an angle like this, we would refer to this as just angle B. So we would refer to it from the standpoint of your vertex. Sometimes, and we'll talk about this in a little bit, we have angles that share a vertex. So we can't just use the vertex to name the angle, and that's where it would be helpful to have the 3 points. So here we can either call this angle ABC, or we could call it angle CBA. In both of these cases, hopefully you notice that the B for the vertex is actually always in the middle. So you would not want to put A or C in the middle on this one. It's always going to be the vertex that's in the middle. Now that we've talked about how to name angles and what angles are made up of, we're going to talk about some of the angle types that we will be using for some of our definitions. One of those is our acute angle. So an acute angle is a little angle. Now, if you think about it being little things being cute, they are angles that measure less than 90 degrees. So you need an angle that looks something like that. Then we have our right angle. Our right angle is the one that's always going to equal 90 degrees. If you think about a square, a 90-degree angle is going to look like the corner of a square, and to go along with that, you often see that little square in the corner, and that's kind of what indicates that it's a right angle. Right, so acute is little or less than 90, and then we have a right angle, which is exactly 90. Our obtuse angle is going to be one that is greater than 90 degrees. And the piece that you might want to add in here is that it has to also be (180 degrees). Okay, so it's going to be greater than 90 and less than 180, so it's going to be between the two. It's almost like taking a right angle and just tipping it a little bit further. So that's what our obtuse angle would look like. And then lastly, we have our straight angle, which is going to equal exactly 180 degrees. And a straight angle is just going to be an angle that looks like a straight line. Often you'll still see the vertex in the middle, and then sometimes you might also see a symbol that looks something like this, just indicating that it's a 100-degree angle. All right, then we're going to start talking about some of our angle relationships or angle pairs that we can have. Our first angle pair that we're going to talk about are what are called adjacent angles. So if things are adjacent, it means that they are angles that share a vertex and a side. Often you'll see an example where maybe we have this angle A, B, C, but what happens is that angle is now split, and now we actually have three angles represented here. So we have the larger angle of ABC, and then we have two adjacent angles that make up angle ABC. So we have angle ABD and then angle DBC. And this would be an example of why we don't want to just use angle B sometimes to label our angles, because then we wouldn't actually know which angle we were talking about. So angle ABD is adjacent to angle DBC. Our next angle pair that we're going to talk about are complementary angles. Complementary angles are angles that add up to 90 degrees. So you might see something like this, and it's going to have that square in the corner. And then you might end up with adjacent angles. So maybe this angle is 40 degrees, and then this is angle Y. And we want to figure out, well, what's the measure of angle Y? If we know that they're complementary and they add up to 90 degrees, we can use that definition to determine what Y is. So we would take 90 minus the 40 that we know to figure out what's left is 50 degrees, which means then the measure of angle Y is equal to 50 degrees. If you've never seen this before, that's what this notation means. So that little m just stands for measure. This is the symbol for angle, like what we used up at the top of our page, and then this names the angle, so in this case it's y, because that's the only angle that we have left here that's labeled. All right, vertical angles, I think are some of the ones that people typically struggle with, but once you figure them out, they're actually really useful to know about. They are opposite angles made by two intersecting lines, and they're always going to be equal in measure, which means they are also what we call congruent. If you talk about two things being congruent, it means exactly that they are equal in size and measure. So going back to our vertical angles, what we're going to do is I'm just going to draw two intersecting lines. And maybe this angle right here measures 100 degrees. And we want to figure out what's the measure of angle X. Since this angle that's 100 degrees is a vertical angle because they are opposite of each other, they are equal in measure, it means that the measure of angle X is also equal to 100 degrees. The other thing that you might see used are what are called these little arcs. So this arc would show that this angle, and then I could put that same arc there. When you see that, it would mean that these two angles are congruent to each other as well because they each have the same number of arcs. That's another way to show congruency. The last type of angle pair we're going to talk about are what are called supplementary angles. Supplementary angles are angles that add up to 180 degrees. A common mistake is switching and mixing up supplementary and complementary. The way that I personally always remember is that supplementary begins with that S, And if you think about a straight angle is 180 degrees, so kind of just tying it into supplementary angles are going to make straight angles, and that's why they are always going to add up to 180 degrees. The thing about supplementary angles is they can also help to explain why vertical angles are equal in measure. If I take that same idea that I just did, and I draw my two intersecting lines, and we'll say that this one's 100 degrees, but now the angle I want to know is angle A, which is right here. Since we can see that the 100 and A are supplementary because they make this straight line, I can figure out the measure of angle A by taking that 180 minus the 100 degrees that we know, which means the measure of angle A is equal to 80 degrees. Going along with that, if A is equal to 80 degrees, we can see that angle A and then this angle down here, we could call it angle B, are also supplementary, which means they have to add to 180. Well, the only thing you could add to 80 to get 180 would be 100, which is the same as the measure up here. And that's one of the reasons why, or the justification for why vertical angles are actually equal to each other or congruent.